ahead and get started here in a minute. We've got a lot to cover tonight. I've got a lot of good information for you, so welcome. Thank you for coming. I apologize for having canceled the last class. I had to have emergency hand surgery in February when it was scheduled, and so that's why I wear my brace. I still don't have any strength or good mobility on it, so you may see me up here clumsily dropping things, and I may ask for some help, but we'll get through it here. So tonight we're going to talk about, I know we billed it as an RO seminar, and we are going to talk about RO systems, but before we get into that, we're going to talk about the need for filtration for drinking water systems and look at the different contaminants that we find in our water sources, not only wells, but in city water. So this first seminar, we're going to kind of run through it fairly quick here, but we want to talk about what's in your water and should I be concerned what's in there. So everybody got a seminar in front of you? These are yours to keep, so you got a pen there, take notes if you want. And I just realized, Tamara, I'm probably standing in between you and the screen here. Maybe I should
You're fine.
stand on this side.
You're good.
So let's get into this. Rarely a day goes by that I don't see something in the media about problems with our drinking water. Now, I probably pay more attention to that kind of thing than the average person does since I'm in the business, but you see reports come across the news frequently on the radio, in the newspapers. I go online and check to see what's going on with our nation's waterways. I get updates from Water Technology, Water Quality magazine, so they're always reporting on different instances that go on around the country. If you go in and do a Google for pharmaceuticals in city water, I did this back in February, there were over 110 million entries in Google regarding that issue, that problem. Well water contamination, 73 million entries. So there's a lot of problems out there. They may not come to the surface and we may not know about them, but we're going to talk about some things that you should be aware of that you can instruct and help your customers understand why they might want to invest in some type of water purification system. So since the majority of people have city water, we're going to start and look at that first here. City water has long been disinfected by chlorine. Goes back over 100 years, and that's the best method of sanitizing and treating our municipal water in the quantities that we have to run through our water treatment plants. Back in the 70s, found some undisturbing news that told us that chlorine mixing with certain organics in the water caused something called trihalomethanes. We're going to refer to those from here out as THMs, and those are carcinogenic. Now, organic matter, as you probably know, is a result of something that was recently living, be it plant or animal. So as that breaks down in the water and comes in contact with chlorine, it produces these THMs, which again are carcinogenic. Estimates indicate that THMs in drinking water are responsible for up to 17% of bladder cancers every year from people in the United States. Cancer is, everybody knows the C word, and probably all of you have been touched by it. My mother passed away from bladder cancer a number of years ago, and I would imagine that probably most of you, well, if you or any of your siblings, parents, or grandparents had cancer in your family, just show of hands, nothing to be ashamed of. How many of you experienced cancer in your family? A good number of you, and I would venture that we all know somebody that's dealing with and going through cancer. So it's very rampant out there, and I think we can contribute a lot of it to what's in our drinking water. So many utilities have switched from chlorine to using chloramines in the water because it produces less of these THMs. Now they do that by mixing chlorine and ammonia together, and there's still some byproducts that are unpleasant. Taste, odor, we get skin irritation, but we have less of the THMs when we're using a mix of chlorine and ammonia. The verdict's still out, though. There are some byproducts generated by chloramines that are strongly suspected as being human carcinogens as well. So chlorination is still the best method of disinfecting our water sources, and so that's how it's done on a municipal level. Anybody know what Indianapolis uses in their water, chlorine or chloramines? Anybody want to take a guess? Nobody knows?
No clue.
Okay, well, they use both actually. Indianapolis uses chloramines about 9 months of the year to sanitize the water. In the summertime, when the algae blooms start to appear in our reservoirs, we feed out of 3 reservoirs into Indianapolis City water, and that's Geismorse and Eagle Creek out here. So in the real hot, humid season, when the algae blooms start to pop up in the reservoirs, then they switch back to chlorine because it's more effective at killing those algae blooms. So we got a combination of both if you're on Indianapolis City water here. Okay. So I apologize because I'm not keeping up with my slides here. All right. We'll look at well water now, and all this information basically comes from the EPA website. There are over 13 million private wells in the United States, and contamination can occur by a number of sources, be it naturally occurring or by human activities. The following slides are going to detail a lot of those things that are in the water that we're concerned about. Start out with microorganisms. There's bacteria, viruses, parasites, lots of bacteria in our environment. In fact, there's bacteria on the table in front of you. I would venture to say that your cell phones have a lot of bacteria on them. I mean, you've seen things on the news talking about that. Restroom door handles, there's lots of bacteria out there in our environment. Some of it's good, some of it's harmful bacteria. I'm sure some of you, I hope you haven't, but I remember eating at a restaurant a couple of months ago, and about 2 hours later, I kind of had Montezuma's revenge. I know I'd eaten something that was contaminated with bacteria, and you're kind of running at both ends. So there's good and bad bacteria that we find. Not all are harmful, but it's very prevalent in our environment. Nitrates and nitrites, we find a lot of those in the water, and those come from a result of chemical fertilizers, human sewage, animal waste, and high levels of nitrates and nitrites can cause serious health problems. We've got some guys here from South Bend, Tom Adamson, one of our dealers up there. I know you have quite a bit of issue in your area. Is that well water up there?
Yep, in the well water, we've had as high as 50 parts per million of nitrates in the water. The maximum allowed is 10.
So when you're going out and doing an estimate per customer nitrates, when you're on well water, nitrates is just something that you standard test for?
Automatically test for nitrates.
And how do you remove those?
With the reverse osmosis
There you
drinking
go.
water system.
Okay, so for people that have high nitrate counts in their water, basically, especially with infants under 6 months of age, water with high nitrates can become a serious health issue because it reduces the blood's ability to carry oxygen through the body. So 6 months and less, they're drinking that kind of water, they can make them seriously ill or even die. Call that blue baby syndrome. You may have heard of that before. Heavy metals, another thing that we run into in the water. And these can be naturally occurring in our stratas that run under the ground. We find arsenic, cadmium, chromium, copper, lead, selenium. There's a lot of things that are in there. And then we also have introduction into the environment from mining operations, petroleum refineries, electronics manufacturers. There's a lot of ways we get contamination into our sources. But heavy metals, people consume high levels of that. It can cause chronic toxicity, liver and kidney damage, and cancer. So one of the big news stories regarding a metal goes back to Detroit a couple of years ago. I'm sure everybody, almost nightly, they were talking about the lead problem that we had up in the Detroit area. They'd switched water providers, and all of a sudden they started having problems with lead, and they did a do not drink order, and the city was passing out bottled water in massive quantities to people. They since have improved that situation, but even as This past school year, September of 2018, 57 of 86 public schools in the Detroit area still have their drinking fountain shut off because they have elevated levels of lead. And the school board approved $2 million for bottled water for this school year because they still don't want those kids drinking the water. So lead can be an issue that we're concerned with. We've had some problems around Indianapolis. It's kind of spotty. We'll share a little bit more of that. The girls are passing out some information on a filter here. Everybody grab one. Our tank manufacturer, Empress, that supplies our media tanks, actually came up with a point of entry filter for household usage for lead and for chlorine or chloramines are in the water. It's a pretty nice system in that it's actually got a meter that counts the gallons of water that are used. I'll flip the top up here so that you can see it. It's green light, it means it's good to go. When the light changes to amber color, it means you've got another month or so. And when it turns to red, it means you need to change that filter. So up until they came out with this, there really wasn't a good method of taking the lead and the chlorine and chloramine out of your water and actually having a meter that measures and counts unless you know when it needs to be replaced. The filter's pretty easy to replace. It's basically just has a snap ring up here on the top. Let me just go ahead and demonstrate it. So basically it's, I'll hold it up here too. Those of you who can't see it, it's got a bypass down the bottom down here so you can bypass the system before you change the filters. It's got a drain port down there at the bottom. Can everybody see that? Set it back down here. So basically, when it's time to change the filter, you shut the water off, you push this red button on the top to release the pressure, and then there's just a snap ring in here that you take out, and this lid just pops off. I don't have a filter in it, but it's a 6-inch filter that's about 36 inches long. You just reach in and grab the handle on top of that, set it out in your 5-gallon bucket that you got there because it'll be kind of drippy and wet. Slap a new filter in it, and away you go. So easy to change. And again, you probably wouldn't be as concerned in the Indianapolis area with lead as you might be with chlorine or the chloramines that are in the water. And this would be a good method of removing those. The filter is rated for 300,000 gallons of treatment for chlorine and chloramine is what its capacity is before you need to change it. And Jane, you've got some pricing you can pass out to people on this. Did you bring a cut sheet on that?
On the lead system, yes.
The Pioneer, okay. You can get that from Jane later on. Another method would be using a point of entry catalytic carbon filter. Now there's not a meter on this that's going to measure and to count the gallons to tell you when it needs to be changed, but a lot of people choose to install a unit like this to reduce the amount of chlorine and chloramines in the water on a whole house basis. By the way, I didn't tell you, but this is rated. If you look at, I don't think you have the cut sheet that's got the information. I don't have a lot of these. I'm going to pass out one per row so you can kind of take a look at it and pass it on down if you would. Sorry, I don't have enough for everybody. But it tells you on the back here, it gives you the flow rates and the gallonage that this unit's good for. And it also has a nice explanation of how the lighting system works on it. So it's a very nice filter, and again, I want you to be aware of that as one of the options for doing a whole house point of entry water treatment system. All right, let's move on to other things on our list here. Organic chemicals. We find those in many household products that are widely used today. Dyes, pesticides, paint, pharmaceuticals, solvents, petroleum products, sealants, disinfectants. Again, if somebody has this in their water and they drink it, it can cause damage to their kidneys, liver, circulatory system, and reproduction system. Oops, don't want to go there. Next one, radionuclides. we don't really have a lot of uranium or radium mining around this area. Some parts of the country they do, but again, that's something that's found in the ground and it can contaminate your drinking water. Fluoride is the last on this page. Fluoride is something that's added to all the city water in this area, and even though it's a very toxic poison, if you ingest too much of fluoride, it will actually kill you, but they administer it in doses that's good for infants whose teeth are in the formative years. That fluoride helps protect and prevent cavities. So we find fluoride in most waters. City and well water can have excessive fluoride in it too, just so you know. All right, let's move on to the next page. This is the big one, fluorinated chemical compounds. It's just been in the last 4 or 5 years that people have started paying attention to this. These are perfluoric octanic acid and perfluoric octanic sulfonic acid. These are heat resistant, water and oil resistant, and they're used in a wide variety of commercial products, non-stick cookware being one of them. Wonder why I got my frying pan here tonight, Jane?
Yep.
The coating in this frying pan is one of these man-made chemicals. If you ever had one of these pans and you notice the scratches on it, stop thinking. They tell you, the manufacturer tells you don't use metal utensils on this because that stuff will come off and it can be harmful to you. Well, pass that around and stop and think about this. If you're using that and some of that comes off, where does it go? Into your food. You're ingesting that, and EPA currently marks unsafe level of these chemicals at 70 parts per trillion, and even 1 part per trillion may pose a health risk. So if you guys got Teflon coated pans,
Throw them away.
throw them away, or make sure you're using a wood utensil or a rubber spatula. That's special material, I don't know what it is, but you don't want to be scraping that stuff off and ingesting it in your food. It's found in a lot of other things too: carpets, stain-resistant clothing, food packaging, firefighting foams, adhesives, cosmetics, leather, and the film inside of microwave popcorn bags. So this is really a big thing on the list that people need to be aware of and remove from their water, if you have it. It's branded the Forever chemical because, again, they don't break down and go away. They'll be there virtually forever. This is a study that the Harvard Gazette did in 2016 about these 2 man-made chemicals, and they reported that 33 states across the United States have problems with these in the water. And again, most of these pages I've given you a documentation down at the bottom, a link that you can go to if you want to look up any of this and study it in greater detail. You're welcome to. At the end of the presentation tonight, I've got a form that I'm going to have you fill out. If you want copies of these presentations, if you get your email address on there and leave it behind, we'll make sure that you get a copy of those. The evaluation form also basically is going to be a registration. We're going to give an RO system away this evening. So if you want to stick around to the end and make sure you get a shot at winning that RO. Okay. Water Quality Association came out Valentine's Day of this year supporting the EPA on taking steps towards reducing the safety threshold for these highly toxic drinking water contaminants known as PFASs, and outlining a program for better monitoring and improving enforcement of removing those. We've got a huge problem in the Great Lakes states. I'm talking about Indiana, Michigan, Wisconsin, and Ohio. Lake Michigan is just full of these, and I can't tell you how many cities pull out of Lake Michigan for their public water resources, but it's a lot of them, so it is a huge problem. Those 4 states have earmarked over $200 million for removal and for study and testing of these chemicals just this year alone. The WQA research shows that these can be successfully removed with a reverse osmosis point of use system, and that's really the best method of getting these out of the water. It would be so costly for a city or a municipality to try to remove these things out of the water. They just can't afford to do it, basically. And when you stop and think about the billions of gallons of city water that are used today, only 2% of that water is for drinking. The rest of it's used for bathing, watering the lawn, washing the car, washing your dishes, doing your laundry. So it doesn't really make sense to make the purity of city water that pure when you're only drinking 2% of it. So basically that comes back to using a point of entry or point of use system to remove those things that are in the water. Okay, next thing on our list. Prescription drugs. Guys, this is another big one. And we all contribute to that, at least I do. I take medicines for cholesterol and blood pressure. So how do prescription drugs get into our water resources? Well, we've got a quote here by Mary Busby, who's Director of Environmental Technology for Merck. If you don't know who Merck is, they're the #2 drug manufacturer in the world. And I quote, Mary says, "There's no doubt about it, pharmaceuticals are being detected in the environment, and there is genuine concern that these compounds in small concentrations that they're at could be causing impacts to human health and aquatic organisms." Doesn't sound good, does it? So how do they get in the water? Well, first thing, people flushing them down the toilet. And I gotta admit, I've done this in the past before I knew better, but when you flush unused meds down the toilet, they go into our lakes and rivers and streams, and consequently they stay there. There's no way really to take those out on a community-wide basis. So don't flush meds down your toilet, #1. #2, for people that take medicines, the body doesn't always have the ability to metabolize all of those. It's estimated that about 25% of the medicines that we take don't metabolize them, so we're avoiding those out of our system. Again, they're going down into the sewer system and into our waterways. So they're there. Prozac, Ritalin, all this kind of stuff, it's in our waterways. Now, I'm going to use an example here to make a point, and I got to tell you all right up front, you can't use it or talk to your customers about this. Everybody raise their hands and swear they won't divulge this to their customers. Come on, I'm not going to tell you. You have to leave the room if you don't raise your hand. Okay. Anybody know where the Carmel sewage waste treatment plant is? Anybody seen that? It's at the corner of 96 and Hazeldale Road. All of Westfield's and Carmel sewage comes down into that sewage treatment plant, and the product eventually is dumped into White River. It sits right there on the banks of the White River. Now, Indianapolis City pulls their water from reservoirs such as Eagle Creek, Morris, and Geis reservoirs, and they have some wells too, but their main intake into the Indianapolis City water system, guess where it comes from? Out of White River. So we got one community dumping all their sewage and waste into it, even though it's been treated. Go down the river 10 miles, Indianapolis is pulling that in. They're going to filter out the big stuff. They're going to dose the heck out of it with chlorine to kill the bugs and the bacteria, but they can't take out the drugs. They can't take out the chemicals that could be in the water. It's going right back up to their customers. Now, if you tell a customer this and use scare tactics to sell equipment, it's an ethics violation, and we don't do that. But I want you guys to understand and know that it is a problem, and if you aren't taking steps to protect your family and letting your customers know that there's a lot of stuff they need to be concerned about, then you're not getting your job done. So understand the gravity of that situation. All right, moving on here. Concentrated animal feeding operations. I know up in the Tipton County, I've got a farmer friend up there that has a hog operation, and they're running 10,000 head of hogs year-round. Stop and think about the waste that comes from those hogs. Where does that go? They take it out and they spread it on the fields. It eventually gets back into our environment, runs off in the lakes, rivers, and streams. Anybody ever traveled west on I-70 or I-80 through Iowa, Nebraska, Kansas, Colorado? Seen the huge confinement operations right along the interstate? There's just literally hundreds of thousands of cows and hogs out there where it's our food chain, basically. Again, think about where all that waste goes. It gets into our environment at some place or another. So these are things that can perk down and get into our watershed. That's the water underneath our earth. They're big rivers and water tributaries that flow under our earth, and it dissolves a portion of anything it comes in contact with. I'm going to read this last paragraph here. This isn't just a problem in reservoirs and water treatment plants. Watersheds are also showing pharmaceuticals in the water table. This means even if you have a spring or well water, you could be exposed to water tainted with drugs. And if they don't just affect humans. A study done in Colorado River found that estrogen-containing drugs in the water were turning male fish into female fish. Stop blinking about that. I know there's some guys who take estrogen because they want to be females and go through that change, but these fish don't have a choice. Our president has banned those fish from serving in the military, though. Nice talk there. Associated Press did a investigation, and they found pharmaceuticals in the drinking water of 41 million Americans. And in Philadelphia alone, they tested positive for 56 different drugs in their water supply. It is a problem. Lead in drinking water. We're not going to spend a lot more time. We've already talked about lead. This cites some cases, I think on the next page in Greentown, we had a problem a couple years ago. Be aware though that if you've got a home plumbing system that's copper and it's before 1986, they were using lead in the solder joints, and that can leach out and cause a problem with too much lead in the household water supply. So we can have, let's break it up here, so that you know what to sell your customer. We need to determine where that lead is coming from. We can do testing to find that out. But if it's coming through the water supply, where they have lead mains or whatever, but if it's coming into the household from the city with lead in it, then we would use a point of entry system to remove that out of the water. If we had a house that had lead solder joints in it, this wouldn't do any good because it's before all that plumbing. You'd still be leaching lead out and people could be drinking it in their homes. So that's when we go to a point of use RO system. It's going to take that lead out. Any questions on that? We all contribute to pollution. I want you to stop and think about the chemicals that you use daily in your household. Toilet bowl cleansers, 409. If you look at these labels, what's it say right there, Kelson?
Danger.
Keep away from?
The children.
Keep away from children. Well, if it's that dangerous, why are we putting it down into our environment in mass quantities? We're all flushing stuff every day. Now multiply that times 127 million households in the United States. We're poisoning our waterways, people. So, what do we do about this? Who's responsible for my health and well-being? Who's going to make sure that my water and your water is safe to drink? Is it the government, the EPA, Safe Drinking Water Act, state regulators, city government? Whose responsibility is it?
You're the plumber.
Mine?
Personal.
The EPA is responsible for regulations and policy that controls drinking water. They set the limits of over 90 contaminants in our drinking water, and they also set up the rules and testing schedules for making sure that the water is tested on a timely basis to disclose what's in it. The Safe Drinking Water Act gives individual states and municipalities the opportunity to set their own drinking water standards if the standards are at a minimum of what the EPA has recommended. Now, maybe that'll give you some sense of satisfaction, but can those standards be enforced? The short answer is not completely. The guy from the EPA, this is a couple years old, said that in the next 20 years or so, $384 billion of improvements would have to be made to our water infrastructure. I'm talking about filtration plants, miles and miles of water lines, storage tanks, distribution systems, in order to bring just the current infrastructure up to standards. We're talking about huge dollars, which is probably not possible to enforce that. So, if you run a well, there's nothing that regulates whether you have to test your water or not. You have to take it as your own responsibility to have that test done. Now, fortunately, there's a couple of good companies that you can go to. If you Google Water Test Corporation, it's through the National Sanitation Foundation, National Testing Labs is the parent company of that. They have a variety of different packs that you can get. You contact them, you pay your fee, and they'll send you a package in the mail. You fill it up according to their directions, get samples of water, send it off. You can have your city water tested, but I wouldn't recommend that. Your local municipality is required to publish a report once a year of what's in their water. So you can probably go onto your city website, Google water, do a search under water, and you'll find their report on there. If it's a well, you probably ought to have the test done and see what you've got. For a couple of $100, this lab will do herbicides, pesticides. I think they have tests for 90 contaminants and heavy metals for a couple of $100, so it's a pretty thorough test. Millions of Americans receive high-quality drinking water every day from their public water system. Nonetheless, drinking water safety cannot be taken for granted. This is copied right off the EPA website. There are a number of threats to drinking water: improperly disposed of chemicals, animal waste, pesticides, human threats, waste injected underground, and naturally occurring substances can all contaminate our drinking water. Likewise, drinking water that is not properly treated or disinfected, or which travels through improperly maintained distribution systems, may also pose a health risk. So the EPA is telling you right now, beware. Understand this presentation is no way designed to criticize your local municipality and say that they are or they are not doing a good job. The intent is to help you understand that the Safe Drinking Water Act standards don't monitor and cover a lot of what's being in our water today. And even if new standards were adopted, it's not feasible that our municipal suppliers are going to be able to put the equipment in place to take all those things out. So again, we'll go back to a point of use filtration system is probably the least expensive way of solving that problem. The fact is that nobody cares more about your health and well-being than you. And unfortunately, we can't assume that somebody else is going to take a more proactive approach to making sure we've got clean water than we're willing to take ourselves. It's your responsibility as a water treatment dealer to make sure that your family and your customers understand the value of point-of-use drinking water equipment and make them aware of the risks and consequences if they don't have some type of filtration. Fortunately, we do have solutions. And we're going to talk about, we've already talked about several of those today. We're going to talk about additional systems that we've got. And I'll just kind of run through this quickly because these slides aren't on your presentations. But we've got the Fresh Point. This is not an RO system, but they're approved carbon filtration systems that are good for removing things that are chemical in nature out of our water. When you get into RO systems, we've got the Fresh Point 4-stage filtration system. We sell a number of different RO units, and depending on where you are and what company you're with, you may see a unit that you're using, and you may see units that you've never seen before. This is a popular unit. It's the Puro Max PC4. We've got the HR3, which has a booster pump on it that we'll discuss in more detail in a little bit. The Microline TFC 335 RO system, which we're going to demonstrate an installation here this evening of this unit. Finally, remember, be cautious about what personal care products you use and how you dispose of them. The impact can have a devastating effect on our environment. So, this wraps this session up. You guys, system removes the majority of everything that could be in the water. Now, I've got a couple of samples of water here, and I'm going to ask you to take a look at those, if you would, sir. You'd be my guinea pig today. Tell me if you can see any difference in those two waters. They're pretty similar color. I like to do this in white styrofoam cups. It kind of reflects if there's anything in there. Sometimes you can tell the difference in them. So, what did your parents tell you growing up about electricity and water?
Doesn't mix.
They don't mix, right? You don't use electrical appliances. Well, that's if your parents loved you. If they didn't love you, they'd hop in that bathtub with your transistor radio plugged in there or whatever. I've got a little light probe here, light bulb, a couple of leads coming down in a plastic tube here. And I want you to understand that actually electricity is not a good conductor. I'm sorry, water is not a good conductor of electricity. It's in fact the mineral content that's in the water that conducts electricity. So while you couldn't visually see a difference in these, we'll go over here a little bit, maybe everybody can see this. If I put this in here and the bulb lights up, that means then it's conducting electricity. Can everybody see that? I'll hold it up back here. So yeah, electricity is being conducted through that water. Let's put it in our pure RO water. You'll see that the light bulb does not light up. Would you be willing to stick your finger in there? Yeah. Didn't bite you, didn't hurt you, did it? Question?
I want to stick my hand out.
Oh, you want to do it? Come on up. Stick it in this one. Somebody said once, hey, you've got a magic switch you turn off when you put it in there so it doesn't light up. Well, actually, let me show you this. I'm going to leave it in there. Watch what happens as I start pouring a little bit of this water in here and mixing it. See the bulb starting to glow? We're picking up mineral content. The more I get in there, the brighter the bulb gets because it's actually conducting that flow. So some people look at these RO systems and think, I can't see any difference. How do I know that it's doing anything? Well, this is one of the little demonstrations we like to use just to show our potential customers that RO system is actually doing something. Put those back over here out of the way. So let's get into the fundamentals of reverse osmosis. Have you ever wondered where your water comes from? There are basically three types of water for use in the home. Utility, for sprinkling, watering outdoors, filling tubs, pools. Then we have household water that we use for cooking, cleaning, bathing, toilets. And then drinking water is the third category that we're going to consume in our household. And again, only about 2% of the water that comes into our house do we actually consume. So, what is osmosis? Osmosis is the movement of water molecules from an area of high concentration to an area of low concentration. In nature, osmosis is the way that plants receive their water and their nutrition. Has anybody ever cut open a watermelon, found a big piece of dirt or a rock in there?
Nope.
Probably not. So you got a melon that grew in a field of dirt and mud here. It actually pulled water through the root system, filtered out that dirt and mud, and nourished the melon with nice, luscious, juicy water. So in nature, osmosis works that way. It's a transpiration of water through a semi-permeable membrane, which is what our root system is. Well, what we do with reverse osmosis is we actually reverse that. We're putting pressure across the membrane and we're pushing water through that cell wall, and basically only the pure water will pass through. The particles that have the dirt and the mineral content are flushed down the drain. That mineral content is known or called total dissolved solids. Now, where's my TDS meter? Hey, Jane?
Yes, sir.
Let me go ahead and pass out these TDS meters. I promised you all a TDS meter if you came this evening. This little one that I got right here, you're gonna get one, but I'm just gonna go ahead and show you how this thing works. Basically, we just push the off on button, and we stick that down into our water, and it's gonna give us a readout of what kind of mineral content we've got in it. If we leave it in there a few seconds for it to stabilize. We can press the hold button on the top. When we take it out, it's gonna tell me that we've got 259 parts per million of what we call total dissolved solids in the water. TDS equals total dissolved solids. We don't know what those solids are during the water. We just know a total mineral count. There could be a half part per billion of a dioxin in there that would kill you, but we can't determine that. We're measuring total mineral content. That's going to be important when we're sizing our RO system and making it work. We're going to get into the different factors that affect the production, how much that unit will make a day. So the TDS level is one of the things that we need to learn. So I hope you put these to good use. They got a 2-year warranty on them. And it's a nice little meter. It's a pocket meter. It also will take the temperature of the water. If you're taking out there and looking at it and reading the instructions, you'll see that it will measure not only the total dissolved solid, but the temperature of the water. We'll figure out why that comes into play here in a few minutes. If we flip over on the next page here, yours is not in color, but this is the spectrum of filtration spectrum of what different filtration applications, what level they remove to. So if you look down at the bottom down here, you'll see that reverse osmosis is on the far left-hand side of your page, and it filters out down to 0.0005 microns. If you look at on the right side, it shows you that a human hair is up there on the scale about 100 micron in particle range. That's about the smallest thing that you can see. As you go down the scale here, you see that bacteria fall in there soon after human hair, and viruses, sugars, dust particles. I think this is kind of interesting, kind of get an idea of what filtration will take out. What you see is produce as much water in that situation. But again, a 50-gallon day system in Indiana with these conditions probably gonna make 30, 35 gallons of water a day. Again, that's probably more than adequate for most situations. I would venture to say that most households with 4 to 6 people don't consume more than 4 or 5 gallons of water a day. So most of these will work ideally in a home. So here again are the 3 things that affect feed water, affect the RO process. Our feed water pressure, that's the net pressure coming into the house, the temperature of the water, the TDS of the water. So now you've got your TDS meter, you know how to test that. It also will test the temperature, so you can make that reading. You'll have to get you a little gauge to put on the outside faucet to know how much pressure you have coming into the household. This is a chart that allows you to take all that information. Jan, I'm gonna ask you to pass out, I've got a copy of this there. It may not be on top, but you scroll down through there. Yeah, give me one too.
Thank you.
Everybody got one? Okay, this is a little chart that's put out by Dow, who is one of the manufacturers of these RO membranes. And it's a calculation chart that allows you to figure out exactly how much water your RO system will put out. So we have this thing called, and it's got an example down here in the bottom that gives you some example. Well, let's run through this on our own and fill this out based on the factors that I'm going to give you here in a second. And just go through a pressure correction so we can see how much one of these units is going to put out. So let's say that we have a TDS coming into our house of 350. So put 350 in that first box there that says TDS after it. Somebody got a calculator on their phone, you might want to pull that up and get a handy one, maybe to divide and multiply here in a second. So this is telling us to subtract 250 from that 350 because that's the factor that this company uses when they produce their membranes. So 350 minus 250 would be 100, right? Then we're gonna, that slash there, so it means we're gonna divide that by a 100. So we're gonna put a 1 in that box there in front of the OPCF, and that's our osmotic pressure correction factor. So if your TDS was 600, we're still subtracting that 250 and dividing by the 100, and then we get that correction factor. Okay, let's put, in the next box down there, let's put our household pressure, and let's say that we've got 53 pounds of pressure, 54 pounds of pressure in our household water coming in. So 54 pounds of pressure on the house, and how do we get that? We got our little gauge. We hooked up to the outside faucet, turn the water on so we know how much pressure is on that household. Okay, now we've got to subtract our osmotic pressure from that of 1. So that's going to give us what, 53 in that box? Okay, so down the next line in step 1, you're going to put 53 as our compensated pressure divided by 60. Somebody got the calculator there?
0.88.
53 divided by 60 is
0.88.
0.88?
Yeah.
Okay, well, put 0.88 in that box there. All right, step 2, that's our membrane size. We've got a 50 gallon a day membrane here, so you're going to put a 50 in that box there with membrane size. So 50 times the 0.88 equals, somebody doing that math for me?
44.
A little louder.
44.
44. So basically, that's saying that that's our, pressure compensation is 44. So put that in the box down there at step 3. Does everybody agree with that 44? Anybody else working that number? Is that right? Okay. So 44 goes in that box down there as our vector we're gonna work with. And then we're gonna look over at the chart and see what our pressure or temperature compensation is. So if you look at the chart on this right-hand side here, you'll see that at 54 degrees, and at 53.6 is about as close as we can go. We're gonna use a factor of 0.661. We're gonna take that times our 44, and what's that give us? Kathleen's fast computing away.
29.
Say it a little louder.
29.
29. Okay, so that's actually how many gallons of water a day when we figure all these factors in, how much water this 50-gallon day unit's gonna make on a daily basis if it was running 24 hours a day. Now, you probably won't have to use this very often, but it's a nice chart to have to refer to. If you've got the problem job where you go out and it's not producing the right amount of water, you can figure out exactly what that unit should be making, and then you can take the line off coming out of the membrane and measure that. And, you know, I've got a little shot glass that I use that measures in ounces. This is a 2-ounce shot glass. It's measured on the side here. It's not really a shot glass, it's for measuring with, but it looks like a shot glass. So if you're making, let's say that you've got a system that was making 24 gallons a day, that's a gallon an hour, right? There's 128 fluid ounces in a gallon. So 60 minutes an hour divided into 128, it's gonna make about
2 ounces of
2 ounces of water a minute. Well, we get our little glass and put it down there and start measuring the water coming out of that. If it's not doing 2 ounces in a minute or 1 ounce in 30 seconds, then we've probably got a bad membrane. If the water comes pouring out of there at real high pressure, we've still got probably a bad membrane too. We can actually blow that out. It'll blow a hole occasionally in the membrane cell wall. Then we get real high pressure coming out of it. But when you test a TDS, it's real high, so you know you've got a bad membrane that way as well. So hang on to this chart if you want some that are not all written on. Again, I can email you a copy of this so that you've got it. But as long as you got the chart, you know how to do the math and make this equation work.
Just a quick question, on the well, would you take the low-high average and then utilize that number?
Yeah,
So if it's
that's a great question,
40,
Tom.
60, use 50?
Right, because it's not always gonna be 40, and it's not always gonna be 60, so average it in about between that. Usually there's a 20-pound differential on your pump pressure switch between the cut in and cut out, so yeah, split the difference and use that back. Okay, installation and startup. I gotta tell you, there's nice instructions that come with every one of these RO systems. And everybody, at least once in their career, if you're gonna install these things, you ought to sit down and read the instructions. Now, real men don't read instructions. I know I don't read instructions very often. But there's a lot of good information in it. You may miss some things. I'm probably not gonna tell you everything you need to know to use this. So sit down sometime and read the instructions. But when we go to start the unit up, basically we're gonna fill the tank so we can pressure test the system. This is the most important thing that you're gonna do before you leave that house, is test and make sure we don't have any leaks. Now at Aqua, a lot of our installers will put these RO systems on a test stand the night before they go out to install it. So when they come in the next morning, they've got a tank full of purified water. They can go install the unit, pressurize it, do the pressure check, dump the water out to flush the carbon fines. We'll get messed up in a minute, and then be ready to go. If you don't have the time or the energy or want to go through that effort, you've still got to get water in that tank. So you can fill it with just the regular water that your inlet to that unit. You can hook it up to this. You'll need a 1/4 by 3/8 reducer coupling to do that. But go ahead and fill this tank with just regular tap water if that's all you've got. So capture a tank full of water and shut that off. Go ahead and hook your unit up, get all your connections made. Open up your faucet and let the air out of the system, and then go ahead and open your tank valve and fully pressurize that system. Then you're gonna check for leaks. All of your little connections, any place that you plug the line in, you wanna go back and check and make sure you don't have any drips at that place. If you've got a drip and you take that line loose, what do you need to do? Anybody know?
Pressure tank.
Cut it square. So recut it square before you
Can't hear you.
cut it and put it, make sure it's square.
Cut a new fresh end on it. You just want a little tube cutter there. Yeah, anytime you take one of these lines loose and put it back in, you gotta cut a fresh end on that, because when you stick it in that fitting, it cuts a little groove around that pipe where that O-ring sits, and it'll probably leak on you the next time out. So cut a fresh end on it, stick it back in there, but pressure check and make sure you don't have any leaks. A lot of our installers will actually get it all put together, and they'll get a paper towel and they'll put it right down underneath the RO system while they're doing this process. And if there's any drips or it's wet before they leave, they know they got a problem. It saves a trip back to the house, believe me. It can happen if you're not real careful. You've got a leak, so you want to make sure, real sure you don't have any drips. All right, so after you pressure checked it and you don't have any leaks, then we're gonna flush the system. We're gonna discard that first tank of water. So we go ahead and open our faucet up at the sink. We're gonna use the water that's in the storage tank to flush these carbon filters. Carbon is gonna have fines on it, and the first water that runs out of that RO system is gonna be black. That's the carbon fines coming through. If the customer is in the kitchen, we're gonna tell them right up front, we're gonna have black water coming out of here. That's just the carbon fines that are washing down. Don't be alarmed. It's not gonna hurt you. You could actually drink that water and it wouldn't hurt you. But if it's unpleasant looking and they aren't informed as to what it is, they're gonna have some serious doubts or reservations. So actually, if people ingest poison and go to the hospital, that's what they actually pump down in their stomachs, is carbon to absorb that poison. So believe me, it's not gonna hurt you. It doesn't look great, but we're washing those carbon fines down. So you let the faucet run until you completely voided the system. All of these new units come with a sanitizer in the RO system too, or sometimes it's an antifreeze, because if they're shipped in the wintertime, they may freeze, and so they sometimes put a little food grade antifreeze in those systems as well. So we voided our tank, we're gonna turn the faucet off. We're gonna instruct the customer at this point now to let that system rest for a couple hours, get another tank full of water. We're gonna be gone from the job at that point in time. We're not sticking around. And we tell them after 2 hours, go ahead and open the faucet again, dump the second tank of water, repeat the process the third time. After they've dumped it 3 times, or they've dumped it twice, you dumped it before you left. But after it's been dumped 3 times, then they go ahead and use that next tank. A step that I left out is that we're gonna shut the ice maker off. Typically, we shut it off at the beginning of the job. We don't want the ice maker calling for water to make ice cubes when our RO system's not producing any water. So go ahead and just flip the arm up on that ice maker. Again, tell the customer after they flush the system 2 more times, they can put the arm down the ice maker and use that next tank of water. So that's basically the startup instructions for these RO systems. Maintenance and service on these. It's recommended from the manufacturer that we change the pre and the post filter. They say every 6 months to a year. The water typically we see around here once a year is very adequate and fine. I don't any places where we change it every 6 months. So typically we're going to alert the customer somehow with a postcard or something, because they probably won't remember that it's time for RO service. When we go out to do that, and we're going to change the pre and the post filter. And if they've got one of these bullet carbons, we'll replace it as well. We're not going to replace the membrane probably for 4 to 7 years. We'll check the rejection with our little TDS meter and make sure that it's still producing good water. And to do that, we take a reading of the incoming water. If it's 400 coming in, then coming out, we should have no more than 20 or so TDS. And typically, when I tell people to replace that membrane, is after you kind of drop below 80% rejection is my rule of thumb. Doesn't have to be what you do. Some people replace the membrane every year, but understand it's the most expensive component part of the system. And the retail on that membrane is about $80 to $100, depending on which one you're going with. Wholesale on it's $30 to $40, depending on what membrane you're using. So if we can get a longer life out of that, we do so. And again, I've seen membranes that are still running after 8 to 10 years and still putting out high quality water. So we change the membrane as needed. When we're out doing the service on it, we're going to check the storage tank and see if it needs air, needs a recharge on it. And again, what's the ideal pressure we want?
7
7 to 9 pounds. If you put in one of these larger RO tanks, I'm talking about a tank that's probably as big as a bladder style tank that would go on a well system. Probably, I remember, it used to be a 202 extra tank. It'd be about 14 inches in diameter by maybe 36 inches tall. We have special RO tanks that's made with a special bladder that we'll use for that purpose. What's the manufacturer we're using now, Kathleen?
Flex wave.
Okay, FlexWave. Those tanks come pressurized to 30 pounds. You actually have to let air out of that tank at your time of installation. Lower it down to the 10 to, on a commercial system like that, I probably would leave 10 to 15 pounds of air in that tank. But that's the one that you'll need to adjust the air unless I'm out of it, because they come pressurized to a higher level. Sanitizing the system annually is something we recommend. Jane and Kathleen got some sanitizing packs. Let's go ahead and break those out and pass them out. We've got a sanitizer that comes from Pro Products that we use. It's designed specifically for RO systems. And there's a couple of ways that you can sanitize the system. I'll wait till they get them all patched out. How many come in a box, ladies?
24
24. So we don't sell them individual packets. You gotta buy a
box.
box of them, but that'll last you for a while. So this has got just the right amount of chemical in it to sanitize an RO system. Pro Products has a real nice online video, and I don't have internet access in here or show it to you, but it actually, write that down, just go to YouTube and Google Pro Products RO sanitizing, and you watch their little video, but basically I'm gonna tell you what they do, and that's basically, they recommend that you take all the filters out of the system. So remove the membrane, remove the pre and the post filter, pour that chemical into the first sump, turn the pressure on, and you're gonna push that chemical. It's gonna go in the storage. Your storage tank has to be empty at this point, I didn't tell you that. So empty the system, pressurize it, and it'll put that sanitizer throughout the system. And I can't remember what to say on there, 2 minutes, I think it has to set in the system. It says right on the directions there someplace. Maybe on the box. Anyway, it's not a very long time period. It's fairly short. You leave the system to set for that sanitizer to have a chance to work. And then shut your valve off of the tank and the inlet. Go ahead and put your filters back in. Pressurize the system. Make sure you don't have any leaks. Go ahead and open your faucet. Turn your tank valve back on, and you're going to use, you've replaced the filters at that point in time. You're going to use the water that's in that tank to flush the carbon on those filters. Again, instruct the customer to let it flush 2 more times before they use it. Now, if you're using this on RO system on city water, I got to tell you that a lot of times we don't sanitize the tank. City water is pure anyway. Jane, if you would, pass out the instruction sheet for sanitizing the microline unit. And basically, the instructions tell you to put a couple of teaspoons of the sanitizer in each one of the housings, the sumps. And when you take it apart, rinse the sumps out, put the sanitizer in there, and flush it through the system. It's not gonna get to the storage tank because the membrane would take it out. But if it's on city water, really it's not gonna have bacteria in it anyway. City water's chlorinated and it's gonna be pure. You really shouldn't have to worry about that tank. If you wanna do the complete system flush, you gotta take that membrane out, get water through it to the tank. Another way to do it would be to take your line loose that goes to your tank and put some solution in your tank, a little dropper, and put some down that line going into the tank. You're gonna force that solution into the tank. You could do it that way. On a well system, it's kind of a different ball game because we do have well waters that have some bacteria in them. Not necessarily harmful bacteria. Did you find them?
We don't have that sheet. We have.
Yeah, I do. I got a microline. That's it. Kathleen's got it in her hand.
The
I thought
technical,
you want the tank sanitization.
I'm sorry. No.
Okay.
That instructions for sanitizing the whole RO system. If you're on well water, sometimes you got bacterial iron, and that membrane's gonna take it out. It'll trap that bacteria, but if it's not serviced and changed on a regular basis, that bacteria will grow through the membrane and come out and go into your storage tank. And I've been out on jobs where you turn on the RO water coming out of that faucet, it smells worse coming out of that tank than it does going in. It's a really contaminated storage tank at that point in time. If you got a tank that's contaminated that bad, I'm probably gonna throw that thing away. You can buy a new one of these tanks for, what's wholesale on one of these, 35, 37 bucks, under 40 bucks for a 3-gallon tank. And it's probably not worth your time to try to sanitize and clean that tank up if it's contaminated at that point. So I would pitch that tank and probably sell the customer a new tank at that point. Go ahead and sanitize the rest of the RO system, but don't try to recover a tank that's that badly fouled. Okay. Any questions on servicing that unit or the scheduled change on that? Okay, let's go on then and look at some service tips here. We want to run, well, y'all got a copy of this? So these are detailed step-by-step instructions that Jane just passed out to you again. I can send that and email to you so you can print those off. And this one is on the microline TFC unit. We have them for some of the other units too if you want them. You have to let me know which unit you're selling and I'll send you instructions for those like that.
the instructions are about the same for,
Yeah, it just doesn't show the picture of maybe the unit you're installing, but the procedures and the steps are virtually identical. Okay, we want to run soft water to our RO system because it's going to extend the life of the membrane and make it last longer. Well, the customer is going to tell you, I don't want to run soft water to the RO because it's sodium and I'm on a sodium restricted diet. My doctor says don't drink soft water. Well, that's okay because the membrane is going to take that sodium out. It's a mineral. It's going to be rejected by that membrane. So we want to run soft water to that. If your house was plumbed for a water softener, there's a good chance that your outside faucets have been bypassed. You got hard water there. There's also a good chance that your kitchen cold is plumbed for hard water as well. You don't know unless you go test it and see what you've got in the household. But that's how, when the house was plumbed for a softener, that was just typical protocol. They plumbed it that way. Well, if we're tapping into that cold sink under the kitchen sink there and it's on hard water, then our membrane's not going to last as long. Instead of getting 5 to 7 years out of that membrane, we're probably going to be closer to the 2 to 3 year life on that membrane. So if you can change that over to soft water, it's going to make the membrane last longer. If this is a well system and that kitchen cold is on hard water, you don't have a choice. You've got to change it. Well water has iron in it around here typically, and the iron that's in the water will foul that membrane in probably less than a year. The membrane's real good at taking the iron out, but it's going to slime it, it's going to it's gonna pack all those little pores that the water's passing through, and then it's not gonna produce any water. You're gonna have to be selling your customer a new membrane 6 months time period. They're not gonna be happy with that at $100 a pop. So you've got to put it on well water, you've got to make the feed soft water going to that. Okay, we always want to run our RO water through plastic lines. As we run it through the RO system, we essentially are making that water more aggressive. We're removing all the mineral content, so it actually lowers the pH a little bit and makes it aggressive. So we connect to that copper line that's run to the refrigerator. It's gonna leach the copper right out of the side walls of that pipe. We're gonna elevate the copper level of the water the customer's drinking, and in less than a year, they're gonna have pinhole leaks in that copper pipe, and it's gonna be spraying everywhere. So you've gotta run RO water through plastic lines only. PEX, polybutylene, any of those will be fine. We don't use any copper in the lines. It's okay to adapt to a brass fitting. If you got a brass fitting on the back of the refrigerator to connect to, that's durable enough that you're not gonna have a leakage problem with that. RO pressure less than desired. We've already talked about the permeate pump. You can sometimes add that permeate pump after the fact, and I've got some instructions that'll walk you through that, especially on this microline unit. We've got a special little kit that we use that actually has that permeate pump mounted on a filter housing like this. And we've got to disable the shutoff valve that comes on the RO, and then we're plumbing this in the line to act as our final post-carbon filter where we're plumbing up this permeate pump. So we got a customer we put a unit in for, they're not happy with the pressure. Ice maker's not making ice cubes, we can come back and add this permeate pump and solve that problem in a lot of situations. Again, if you know going in up front that you're gonna be installing that unit in a basement or some great distance away, then you probably want to use that system with a permeate pump right up front. If you are running your supply line more than about 25 feet, you want to upgrade to half-inch PEX. Now I like, basically if I'm running a supply line for an RO system, I like to use PEX. We sell this PEX pipe, it's a little bit more expensive, but it's very durable. It's not gonna kink or break down on you, and it'll be there for years. We a lot of times plumb in a house in the rough end stage in construction. We'll plumb in a distribution system for an RO and feed it to multiple places in the house. That's another PDF you girls can pass out now. We'll talk about that for a minute. But if you're running more than about 25 feet, you ought to upgrade to this half ID 5/8 OD size piping, because you get a lot of friction loss in this smaller line, and your customer may complain of pressure the further you have to run that. If you end up running a great distance of that pipe, you may want to go ahead, say we're running from the basement up 40 foot to the kitchen sink. When we get to the kitchen sink, we're going to feed the faucet and then go over and feed the ice maker. It's a good idea to go ahead and put a bullet carbon filter up at that point, because sometimes on that new plastic pipe you'll get some taste throw when it's new, and especially the more pipe you have in the line. So one of these bullet filters will clean that up and avoid a call back from a customer saying, I got a plastic taste of the water. But anything up to about 25 foot, you can go ahead and use the 3/8 inch pipe in there. Always turn the ice maker off at the beginning of your install, and instruct the homeowner to turn it back on after they flush that tank the third time and they've got a tank full of water. If you're going to run a line to the refrigerator, we want that shutoff valve under the kitchen sink. It doesn't do any good to put that in the line on the refrigerator line behind the refrigerator. Customer can't get to it to shut it off, they got a problem. So if your point of origination is coming from the RO under the sink, go ahead and put that valve down there so they have access to shut it down if they need to. Just a note here about checking the pressure again. Never leave an RO system until you fully pressurize it and check it for leaks a couple of times. when installing a saddle valve for your drain, we want to keep that as far away from the garbage disposal as we can. Now, my little sink here that I brought for this demonstration, you're probably not going to install any ROs in a sink that's this size. Most of them are going to be 36 inches and maybe have 2 bowls, but for me to haul this around in my car, this is what fits the best. So a little bit undersized sink, but most sinks will have two bowls coming out of it, 2 strainers. Garbage is supposed to be on one side. We want to hook our drain line saddle valve on the other side as far away from that garbage disposal as we can. Now sometimes it's just a 1 bowl sink and you don't have any choice. You still have to connect onto that line coming out of there. But get as far away from that garbage disposal as you can when you connect that saddle valve. You actually can mount that either in a horizontal or a vertical position. So if you've got a horizontal pipe in there, you can connect that saddle valve to it. You don't want to come in the bottom of a pipe like that because you'll still get debris plugging it up. So put that saddle valve on the top or maybe at a little bit of an angle to one side. Again, that keeps debris from stopping up in there. So again, keep that saddle valve as far away from your garbage disposal line as possible. Installing ear gaps, we want to make the drain line from the faucet down to the drain as short as possible. I'm going to demonstrate that in a minute in our installation, so we'll cover that a little bit more thoroughly. We've already talked about flushing the system, sanitizing, checking the air level in the tank. Last thing on this list is using a calcite filter to raise the pH. Because the RO water is so pure, sometimes you have your customer may complain a little bit about the taste of it because you've taken everything out of it. Or you may have a copper line that runs under concrete that you can't change. You've got to be the refrigerator, you've got to connect onto that copper line for some reason or another. We can actually put a calcite bullet filter in the line, and as the water passes through this calcite filter, puts a little calcium in there, it's going to buffer the pH, it's going to raise it up a little bit. It'll also give a little mineral taste to the water. It's not going to raise the pH of the water very much, or it's not going to raise the mineral content of the water very much, but it'll neutralize that lower pH and give just a little bit of taste in it. Now, you don't want to install this just in the final line coming out as it goes to the faucet. It actually needs to be installed back the water coming off the membrane before it goes to that storage tank. We do have specific instructions on where to install that if you're ever going to get into that process. Okay, moving on. Again, let's go through this in a little more detail now. The PuroMax is the unit we've got here. It's a 50-gallon-a-day unit. It uses, question?
Why you can't install that after the holding tank before it goes to the faucet?
Because it doesn't have enough contact time to dissolve the calcite. It needs to run through that on a slow, have contact time for it to dissolve. If you put it on the tank side and it's going through there real quick, it's not going to buffer and raise it up enough. Good question. Okay, no, Tom.
Just a tip, a sign that a drain is clogged is water will actually come out of your faucet. Your customer will come and say, I have a leak on my sink, there's water coming out of the faucet. And it's generally in situations where you do have a garbage disposal and you don't want to be running back doing free service calls. You can actually put in a small backflow preventer right by where you plug into your drain. Will completely eliminate the problem. So it's a good tip for them. Those little, and you carry them. Aqua Systems carries them.
Yeah.
They work fantastic.
Yeah, thanks for bringing that up. We actually, in some states, I have it out here, it's against the law to use this saddle valve under the sink, so we actually, I think it's Nebraska where it's outlawed, I don't know if any other states, but we actually have a T-fitting that's got one of these on it that you can use that in a situation where you can meet code standards. Okay, it's PuroMax unit. It uses all NSF Everybody know what NSF is? National Sanitation Foundation. It's a agency that tests and certifies products that, yes, it meets a certain standard. So all of the ingredients that go into this unit are NSF certified, but it's not certified as a complete unit, how it's built up. Consequently, it's a little bit less expensive. It's a popular unit because your wholesale cost on this is probably less than $140 wholesale, and for an NSF approved unit, you're gonna pay a couple $100 for that. So it's still a good unit. The quality of water coming out of it will be as good as any of the approved units. If you've got a customer that's hung up on certification or approval, you may wanna sell them the NSF approved unit. We've got a nice literature sheet that has all of the typical RO systems that we sell on it, and it's got the filter replacement cartridges that are needed on it. I'll have the girls pass that out to you while we're going through this. MaxFlow HR3, it's this unit over here. It's the one that's got the permeate pump built into it. It's under $200 for that system. That permeate pump does a great job. It's non-electric. I've had one in service at my house for 15 years and have never touched that permeate pump. I will tell you that there's a little secret though that you need to know, and that's that this permeate pump has an arrow on the side of it. Where's the one we passed around? Somebody got that? We can probably see it. Back up here. Let me use that. Great, thank you. So it's got a little arrow on the side that's pointing up, and when you install that in the bracket there, you're hooking the pipes up to it, it may get moved around, but when you're done, you rotate in that bracket and make sure that arrow is pointing straight up. If you don't, and it's on the side, when you go to change the filters, you'll get some air trapped in that, and this thing won't work properly. So after you change the filters, you got a customer that says it's not working, that may be the problem, is that arrow is not pointing in the up position. Something I didn't disclose that I feel the need to is that if you install this unit underneath somebody's kitchen sink, you may get a complaint about the noise that this pump makes. Now, it's not a lot of noise. It's about every 7 seconds you'll hear a, and it's, you know, somebody's real sensitive, it may bother them. Again, this is more for a remote install in a basement or mechanical room someplace where you're gonna run the water a big distance. If you really want the pressure and they want it under the kitchen sink, we can do that, but just forewarning that it's got a little click as that piston forces the water through the chamber and into the tank. It's not real offensive, but it is there. Again, this is, all components are NSF approved, but it's not certified as a complete unit. These units actually come in the box, built and put together with the filters actually in the sumps, and all you have to do is put the membrane in it. It doesn't come with the membrane in it, so you'll need to disconnect the red line on the side here, unscrew that housing, put the membrane in, and screw it back together again. Fresh Point, this is a newer unit that we've only been carrying now for a little over a year. It's a Pentair unit. A lot of people like it because it has the easy change cartridges on it. It is NSF approved as a complete system. You'll notice on the feature sheet there, it says it's got a 75 gallon a day high efficiency membrane on it. It's been rated at, for every gallon of water that it makes, it only runs 1 gallon of water down the drain. On the unit with the permeate pump, we're running about 2 gallons of water down the drain for every gallon we make. And on this unit, the Puro Max, we're running about 3 gallons of water down the drain for every gallon we make. Now, some people complain about the waste, but if you stop and think about it, if you're drinking 4 gallons of water a day, that's 12 gallons of water that's gone down the drain. To make that, it's like flushing the toilet a couple times. It's not a lot of water, but if you got somebody that's a real environmentalist and they want a high efficiency unit, this one is a true 1-to-1 ratio, and it's a higher production 75 gallon a day system. The nice part about this are the filters. When you go to change the filters, It's actually got a valve in the head of each one of these filter housings here. When you flip that handle up, it shuts the water off, pull the filter out, throw the whole cartridge away, slap a new one in there, lock it back in place, and you're done. So for a customer that wants to do their own service and maintenance on it, this may be a little easier for them to do. If you're a service company and you want to do the service on it, then it may be a reason not to sell them this unit. Sell them one that's you've got to go out and maintain. I'm not going to tell you what products to sell, but this is a nice unit that is NSF validated and approved. It meets standards 42, 53, 58, and the CSA 483.1.
So is the
those are all-
lifespan about the same on the filter?
Lifespan, yes, 1 year. Actually you have 3 that you change once a year, and then the membrane, again, is 5 to 7 years you can run soft water to it.
Are those filters pre-flush, so you do not have to flush the system?
No, you still have to, carbon fines will come off of it, so you gotta flush them. Okay, next on the list here. Did you guys pass out the sheet on this, the larger RO system? Yeah, you got it in front of you here. For those of you that may want to install a larger RO system, you've got a sheet here that kind of shows the layout on it. And this is a picture of the screen of what we call our AQLP 100. And it comes with a permeate pump on it. As you can see in the picture there, it's got the permeate pump on the bracket up here. Got the larger storage tank on it. This will be a schematic of how you might put this in a mechanical room. Install your RO, run down your storage tank. Then the line out of the tank, it's going to be probably a 3/4 or 1 inch line coming out. We'll do a post Big Blue carbon filter, and then you'll have individual feeds for all of the pure drinking water faucets in your house. So if you're working with builders and you can get in there in the rough end stage and they want pure water to various points of the house, this will give you a schematic on how to do that. We quote these at the time of need. We can give you a price on the pump and the tank, but obviously, depending on how many different faucets they want in the house at different locations, cost is going to vary on some of those things. So wanted you to have that schematic so you understand.
Is it still 7 PSI in that big tank?
Gonna be between 10 and 15 pounds is what you're gonna leave. That's the one you're gonna let air out of. This is not a flex wave tank, it's in the picture, this is an older picture, but yeah, it's gonna come pressurized about 30 and you'll need to let air out of it.
And what size of lines are you running to each fixture? Are you still running like a small 3/8
Again,
or?
it depends on the distance, but usually we're running the 3/8.
Okay.
Yeah. Like I've got a faucet in my master bathroom at my house, it's on the 2nd level, and it's going a distance of about 40 foot, but it's a faucet where I'm just using it for brushing my teeth and not a big volume. So 3/8 in that case is
Okay.
big enough. You don't need to run a 1/2 inch line just to go feed a little faucet where you're gonna draw a minimal amount of water.
Okay.
Okay, this actually shows a picture of even connecting our RO water, instead of having a 3rd spigot up there, this is the bedroom sink up here, and instead of installing an RO faucet, we're actually feeding to the cold side of that faucet in the bathroom, which you can do if it's a lead-free faucet. But what you've got to do is you've got to put a check valve in the cold side, because if they would turn it on the hot side and the pressure would be greater on that than on the RO system, it could push water back down to the RO system. So you got to put a check valve in there. It's easier just to put they've got room just to put another drinking water spigot at that point, but I've seen people that just put it out the cold side of the faucet. So you've got that schematic, and we can help you quote those upon request. Okay, we're going to take about a 5-minute break, so if you need to hit the ready. All right, we're going to go through an actual installation on an RO system here. So you can see the steps, what we need to do to get one in place and get it checked out. I like to have a couple of boxes of John Guest fittings. I brought these so I can show you what I've got. A couple different boxes of all different types of fittings and connections. I've got a box for 1/4 inch fittings, and I've got another one for 3/8 inch fittings with valves and reducers and that type of thing. If you're going to be putting just an RO under a sink occasionally, you probably don't need this, but if you're going to get into making runs to multiple places in the house, you really need to have a good assortment of fittings to use to make sure you have the right connections at the right time. Okay, so I actually chose this Microline TFC unit primarily because it fit under the cabinet a little bit better here with the smaller tank and with the manifold system. And again, this is one of those RO systems that requires a little more effort to put it together. When it comes in the box, it's all separate here. You've actually got to install the canisters, put the filters in, and we'll go through those steps in a minute. But let's look under the sink here first of all at our connection point. Get this tank out of the way. So we've got our cold water supply here under the sink, and you'll have a shut-off valve of some type and a supply line going up to that sink. And when we go to install into this line, there's a couple of different ways that you can do it. We'll shut that off. I like to use, and I'll pass, we've got a couple of different fittings that we use here. I'll pass these around for you to take a look at. Now, incidentally, there is a saddle valve that comes with each one of these RO systems to tie into your line. We throw those away. They're not approved for use in Indiana, so that's why I'm passing these others around so that you can see what we do. So this particular one I'm passing around, it's really easy to shut your water off. We're going to take our supply line loose here, and we'll attach this in its place. It screws right on to where our compression fitting came off. And then we can put our supply line right back on the top of that. And now we've got our 1/8" feed is the right line size for our RO system. We've got our valve there under the sink. You may have different materials there. If you've got a PEX supply line going up there, you can actually just cut into it, put a T in the line, and put a shut-off valve on it of another type. Might be a little bit cheaper, not necessarily a lot, but there's a lot of different ways that you can get into it. I think that's the easiest one. There's two different types of those going around. The second one is, so it'll go to a 1/2" connection over the sink as well. So that's going to be our feed to the RO system. Next, we're going to put a couple of screws in the sidewall to hang our RO system on. Now, I like to get the RO up off the floor. Some people just put it in there and let it stand on the floor against the counter, but it could tip over or move around in there, so I like to get it secured. So I'll put a couple of, you need to use a number 8 or a number 10 pan head screw, probably no longer than 3/4 inches. If you go too far into the cabinet, if you use a 1" or 1.5" screw, it could go into the cabinet next door and somebody might get their hand on it. So don't use a screw that's too long. I carry a little level. I like to make sure things are plumb and up there level, so I put those screws in at the same depth. Okay, so we're going to look at our RO system. I got all the components laid out here. If you're buying this brand, this Microline unit, it actually has little plugs where our 4 lines attach, and they're color-coded with the color of pipe you're going to put in that plug. Our blue is our supply line to the sink. Our red is our connection to our water supply coming into it. Our yellow coming out of the top up here is our tank line. And our black one, it's actually gray. My dog chewed up the black one, and I didn't have another black one. But the gray one here is the drain line that comes out of it. This particular unit, it actually has embedded in here what the different things are. It says pre-filter, membrane, post-filter, inlet, drain, and supply line. So while they're small and you can't see it, they're actually marked. Also, the filter connections are marked so you know what filter goes where. The pre-sediment carbon goes in this first cartridge, and it actually is a 5-micron sediment filter, and then it has carbon in it as well. Now, it's important on our pre-filter that we're removing the chlorine content out of the water, because these membranes, TFC membranes, won't handle a lot of chlorine. It'll actually ruin them. So that's why we've got a carbon pre-filter on all of our systems. notice that it's got the double O-ring seal at the top of that filter. It's a little bit more of a positive seal rather than one of these, what do those filters?
We're sitting on the table.
What? Say again? Oh, you're hiding from me there. Thank you. Notice this filter, it's just got one big washer up on the top of it, and that forms a pretty good seal, but it's not gonna be as good a seal as a double O-ring seal. So a little bit higher graded product there. So we're gonna insert, actually, you're gonna take the plastic off of it. And I missed a step here. Before you start handling this filter, you're gonna wanna put on some gloves. You're handling a sanitary drinking water product here. You're touching these parts where their drinking water is going to come, so I'd recommend that you carry a box of nylon gloves that you're going to use when you handle these products and putting it in and or doing the service. So we'll install our filter in there. I'm not going to do it now just for the convenience of saving time. Also, this one you actually have to install the O-ring in the top of the canister here. There's a little groove down there. We're going to put it in place. They come pre-lubricated, so you shouldn't have to add any grease to it. This is the part where I'm clumsy, guys, because of my hand surgery here. It's not working very well. So we're going to screw our canisters in place. Membrane goes in the medium or the middle cartridge here. Again, I'm not going to do it because it's all factory sealed and sanitized, but we'll insert it, then screw our canister on. And then our last one is our post carbon filter. So we've got our filters in and our cartridges in place. I'm going to recommend that you go ahead and connect some of these pipes at this point. What we're going to connect is going to be our tank line, which is the yellow one, and it's going to go in this point up here. Our blue is going to be our faucet line. And our red is going to be our inlet to the system. We'll get those all in place, then we're going to go ahead and hang the unit on our brackets here. Now I carry zip ties. I kind of like to zip tie these lines together and make a nice looking installation. Looks like a craftsman done when I get finished with it. A lot of people leave the lines just curled around in there all over the place. Then in that case a homeowner can reach in there and grab something and snag one of those lines and maybe cause us a leak. So it's nice to get them coiled up. I don't cut these off because when somebody goes to service a unit a year from now, it's kind of difficult to do inside of here. They may want to take that housing off and set it out here so you can set this in a pan, because when you unscrew that you're going to spill some water. So if you let that line on it, they've got enough that they can pull it out of the cabinet. So for that particular reason, I don't cut those lines. Next, we're going to look at putting our faucet on. I like this Tomlinson style faucet. It's a high-end faucet. It's got an air gap built into it. You can use it as an air gap or a non-air gap. I'll pass that around if you want to look at it. I've already got the parts all out up here. We're going to go ahead and put one of these faucets on. So here's our base. Our air gap device is going to go in here. And this is what the air gap part of it looks like. We're actually going to connect our smaller line, our 1/4 inch line, onto that nub coming out of it, and our 3/8 line onto this nub coming out. And what happens is the RO drain is bringing that water up through this 1/4 inch side. The water's coming up here, making a U-turn and going back down the 3/8 inch side to our saddle drain valve down there. If for some reason that gets stopped up, the water's gonna come out of this little U-turn here and come out the hole in the side of this, which Tom was talking about earlier. It's gonna come out the hole in the side of our faucet and spill into the sink. That's what's making our sanitary block between our sewer and our sanitary water. So when we put this together, I went ahead and already connected the hoses to one of these just to conserve time, and then we've got a little gasket that we run up there, and that's gonna be in between our faucet and the base of the sink so that water can't spill back down in the bottom of the sink. We're gonna go ahead and, Kelson, would you help me take this off here?
What do you want?
Let the base, no, this is the sink part. Oh, we still got our supply line connector here. Let me take that off real quick. Okay, now we take it off here. I thought for the purposes of doing this, let's go ahead and set it right here. Thank you, sir. It'd be easier for you folks to see this. Tamara, can you get a good shot of that? We talk about cutting the hole in these sinks. There's a couple of different things that you can do. First of all, if the customer's got a soap dispenser, maybe they're not using, you can suggest that the faucet go in where the soap dispenser was. If they've got a sprayer that they're not using or willing to give up, you could put it in that sprayer hole. If you have to cut a hole in the sink, there's special tools that you can get to do that. Even if you got this type of service, or you've got a granite countertop you've got to drill, this is a very inexpensive device or bit here that's actually diamond encrusted on the drill part of it, and it's got a little reservoir comes with it. I'll go ahead and show you how it goes together. Determine where you want your hole at. Let's say we're going to put it on this side over here. First of all, check underneath the sink and make sure there's not any struts or thing in there that's going to get in the way of your faucet coming down under that sink. Sometimes it's pretty tight in there, so make sure that you've got adequate room for the underside of those components that are going to go in there. Once we've determined that place, we're going to go ahead and attach our little rubber ring there. Then we've got this little device that's got a well in it, and we're going to go ahead and stick that in place. And we go ahead and put our drill bit in our drill. And before we start drilling on that, we're going to fill this cup with water. That's what's going to keep our diamond drill bit cooled while we're drilling. So we're going to go ahead and start drilling that hole. You'll immediately see the fines. If it's granite, you'll see the little pieces of granite color that water. It'll turn a milky white. It takes about 5 minutes to drill a granite countertop with this. With a sink like this, it'd probably be through it in less than a minute. But if it's on a granite, I'll drill for a couple of minutes, and the water will start to heat up a little bit. I'll take a break. I'll take a paper towel, soak up the water that's in there and the little granite fines, throw it away, put another cup of water in there, and go ahead and finish drilling it. It makes a nice, clean hole. Talk with your boss before you drill a granite countertop. Sometimes they get pretty expensive, and if you mess up, it's an expensive fix. But this indeed is a great little tool to use to drill those with. And you can buy these at Lowe's or online for about 20 bucks. They're not real expensive for this. And you get half a dozen gaskets. It'll probably drill. That diamond bit will probably last for 8 or so drills. Okay, we're going to go ahead and mount our faucet on here now. Okay, so we've got our little air gap here. Basically, we're going to put our faucet stem down through this base, and there's a little hole in this air gap. We're going to go ahead and put that through and make sure that our faucet washer's in place. And we're going to run these lines through our sink base here. have all my tools over here that I need. Okay. Now, when we attach, okay. Next thing that goes on is this little keeper that's basically gonna butt up against our countertop on the top side. It's a little white plastic piece. It's gonna go on here like so. Next, we're gonna install a lock washer. Then we've got a flat washer we're going to put on. And then we've got a nut that holds that all in place. This is on the supply line where our pure water is going to come out. Run that up there a ways. Basically, we want to get our washer centered under that faucet. Then we're going to insert this last piece up here and then tighten. You go ahead and spin that nut down for me. Pick that up first more. As I said, I'm a little clumsy here with this hand. Once you get that inserted, if you'll just tighten that nut down for me until it gets a little bit snug. Appreciate your help.
Sir.
Now, you're getting there. Okay, now I like to, that's good, stay there. I like to carry with me a deep socket. It's 9/16. It's easy to put that on there and finish tighten it down if you've got a deep enough socket. If you don't have one of these, or you've got an extra long stem on a particular type of faucet that you're using, you may need an end wrench, 9/16 end wrench, to tighten that nut down with. Now, if you're laying on your back under the sink, usually you don't have the ability to take that sink top off and do it. I'm just doing this so you can see it a little closer. But you don't really have room under that sink sometimes to use that end wrench to spin it. So if you buy a wrench that's got a 90-degree swivel head on it and you're under that sink, you can put that on there and tighten it down basically from the bottom side without having to bust your knuckles or so. It's good to have a variety of different tools in your toolbox so that you've got the right one you need when it comes time to put that together. Okay, now we're going to add, go ahead and put our faucet stem on here. It just kind of sits in place and we'll tighten that down. Mr. Kelson, I'll use your help here again. Set this back in place. Sure. All right, good enough. Except our faucet's kind of at a weird angle. I didn't get it on there very good, but it'll suffice for now. Now, I would probably ask my customer before I cut the hole in the countertop which side they wanted that faucet on or which way they wanted the handle to point. Some people left-handed may ask for the faucet on this side. Some other people may want it on the other side. So before you make a permanent installation there, you might find out what their preference is. Okay, we've got our lines pulled down through here. Let's look at setting our tank in there now. These tanks come without the valve on the top of the tank, so we've got to add our shut-off valve to that tank. We do want to put some Teflon tape on here before we screw our valve on, and you can get it tightened up with your hand. You don't need to put a wrench on this to tighten it down. Just snug it down with your hand and you can set that in place. On our drain, we've already talked about this a little bit. You're going to get this drain saddle valve, and it's designed so that it splits and puts around the outside of the pipe. You've got this black washer that's going to secure snugly down on the sink so it doesn't leak. And we're going to use a 1/4-inch drill bit to drill our hole into our pipe wherever we decide is the best place to have this saddle valve, and it's going to be as far away from what as we can get it.
Garbage disposal.
Very good. Okay, well, let's go ahead and put this in place up here for right now. And then I'm gonna step back here so you guys can see a little bit better and go ahead and make my connections here. Try to do it in a neat fashion. So, I know you can't see these lines back here, but you saw me hook them up. So now we're gonna run our tank line, is the yellow one. Let me go ahead and get this back out of the way here. We'll connect our supply line back up to our cold water faucet just for the sake of getting it out of the way. Okay, our yellow is going to connect where?
Tank.
Into our tank. Our blue is going to go up to our faucet. Now we haven't put our faucet fitting on yet. It comes in the package. You see it's got a black O-ring in there. We don't need to put Teflon tape on this stem coming down from our faucet. When you tighten that down, it'll tighten down on that black O-ring and seal the unit. So we're not going to put any tape on that. We're just going to screw it on there. And again, it's almost hand tight is good enough. You might put if you get it screwed on as far as go, you might put a couple of turns on it with a wrench. But it doesn't take a lot to seat that in place. So we get that in place. We're going to connect our supply line up into that. Our red line is going to come into our little valve we installed under the sink. And I kind of like to make a neat package as I can with these lines. Like I said, put a zip tie on it so we're holding that all in place. So we don't have lines running everywhere under that sink. Now the only two lines we have to hook up yet are the drain line going up to the faucet and coming back down. This one actually, again, ties into the back of the RO here. Should have had that in my bundle and I didn't. And again, it's got the little flow control in the back of that, so we want to make sure we don't cut that flow control out. And then all that's left is our air gap line that's coming back down out of the faucet that's going to tie into our saddle valve here into the sink. Now this is the one line that we're going to cut because we want to minimize any extra pipe that we have there so it doesn't create a place for garbage or gunk to collect in it. If we double that around, it just gives us more surface area for something to stop that. We're going to take this basically cut it off so we got pretty much just a sweep that's coming down from the faucet and right into that saddle valve on the side. So our unit's set up and installed, ready to go. If we brought it out to the house with a tank full of water captured here, then we're ready to pressurize the system and check for leaks. If we haven't put water in it, we're going to go ahead and take our inlet to the system and pressurize the tank to check for leaks in the system. Once we've checked for all of our leaks, we're going to go ahead and open the faucet, the inlet valve to the RO down here, pressurize it. It's good to go ahead and open this faucet up here because you're going to void some air out. As those canisters fill, you'll have some air that goes ahead and kicks out the faucet up here. If you leave your tank shut off at this point, you're not trying to feed water to that tank. You're just voiding the air that's in the system here. So once you have some water starting to come out of the faucet here, we got all the air out of it, then I would go ahead and shut that faucet back off, open the valve on top of your tank, and now we're pressurizing the system with the water that's in that tank. We're going to check for any leaks that we may have on any of our fittings that we put together. We've certified that everything's dry, and then we're going to go ahead, turn our faucet on, use the water that's in that tank, to flush our carbon filters, wash those carbon fines down. So we'll let it run until all the water comes out, or it just basically comes to a drip up here, which is just gonna take a minute or two. Once it comes to a drip, we're gonna shut it off. At that point, instruct the homeowner, wait 2 hours, dump it again, wait 2 hours, dump it again. So it has 3 flushes altogether, the one we did and the 2 the homeowner are gonna do. After they flush it the second time, they can open up the line to their ice maker and refill their ice maker line. The other thing you may want to add at this point, we should have done this before we pressurized it, but again, if you're going to feed a line to the refrigerator, basically we're just cutting into our blue supply line that's going to our faucet. We're just going to cut in that, put a T in the line with another valve that's going to be a shut off for a refrigerator. So we'll put it in that line someplace. It's going to feed our refrigerator. Now we've got our shut off for that. Any questions at all on the procedure and the setup of that system? They all pretty much plumb up the same way regardless of what type of unit you're putting in. Some of them are a little bit easier because you don't have to screw the filters on, a couple of the ones that we sell. But they all pretty much plumb up the same way. If we were going to sanitize this complete system, let's run through that again. Gene, have you passed out, what have you passed out?
Everything.
Okay. All right. We've already passed out the sheet on sanitizing, but let's just walk through that again. If we were going to come in after a year and sanitize this system, the best way to do it to completely sanitize everything, take all 3 of the filters out, and we've shut off the water to the unit at the top of the tank here, and then we're simply just going to take this first sump off and put our sanitizer in that first sump, screw it back on, pressurize the system by opening that valve, and open our tank back up. Our tank should be empty when we do this. We're going to run that sanitizer throughout the whole system. Once that tank is full and the water quits running, we'll shut the valve on it. We'll wait the allotted amount of time, which is something like 2 minutes. Then we'll go ahead and shut the water off again, remove our sumps, put our filters back in, turn it back on again, pressurize the system, check for leaks, open the tank, flush that sanitizer back out, then have the customer do that 2 more times after we've sanitized it. So that would be how you sanitize, again, the whole system. Any questions? Looks pretty easy, right? It's not really tough once you've done it a couple of times. Now, if we're going to troubleshoot this unit, Jane has passed out, or Kathleen's passed out a troubleshooting sheet, and I'm not going to go through everything that's on that. It's this one, this front and back here, and it talks about different things to look for. I think it's all pretty descriptive, so we'll not address all those things. It's really pretty simple. The system either makes water or it doesn't. If it's not making water, then you've probably got a plugged filter someplace. Membrane's bad, or you've got a plugged up pre-filter that won't let the water pass through. Basically, you're going to take the system apart, change the filters. If you've got a system that is low pressure, we're going to check for the amount of air that we have in that storage tank. And again, it's pretty simple. And I just basically take you got a bicycle pump, I don't know what I did with it.
Right over here.
Here someplace, thank you, sir. I just use a regular bicycle pump, and it only takes a half a dozen pumps. Once you hook that onto your tank there, to get the right amount of pressure back in it, and you need a gauge to verify that you do have the right amount of air back in it. But some guys carry an air tank on their truck. That's a pretty nice bicycle pump. You don't even need one that big, just something to get air into that tank. When the customer calls and says, I only get a cup of water, and then the pressure goes down to nothing, that means you don't have air in that tank. You can go out and you can kind of tap the sides of the tank or feel the weight of it. If it feels full of water, you're not getting any flow at the sink, then you've got all the air escaped out of that system. So in that case, what we would do is we would shut the water off to the entire system, let the pressure off of it, go ahead and remove our tank from the system. Basically, I like to take the tank out, take it outside, go ahead and open the valve, and let all the water run out that will. Then I'm gonna, on this one, the sniffer valve's on the bottom, I'm gonna attach my pump and start pumping air into it. As I add air to it, it's gonna force the rest of the water out that's in that tank. Because we're adding air, it's gonna discharge all the water. When the water starts coming out, that's when we start, measuring till we get to the 7 pounds. We wanna capture that 7 pounds of air. Now, if our water all runs out and then we start having air come out up here, what's our problem?
Long bladder.
We got a hole in our bladder, and that doesn't happen very often, but it can happen. If the air's coming out up here, that tank's bad. Throw it away and put a new one in it. These Pure Choice and Microline come with a 5-year tank warranty. Most of these, I think the PC4 is a 2-year warranty on it. So typically if they fail, it's gonna be 5-6 years down the road. But again, the tanks are pretty inexpensive. So again, once you've got the 7 pounds of air in it, again, put it back in service, fill it up, and away you go. Okay, any more questions on service, install, anything? You're an awful quiet group here. Okay, well let's do a wrap up here.
I have a quick question. What exactly is the membrane made out of? Like what material or?
It's a man-made membrane. I really can't tell you.
Okay.
I don't know. Does anybody know? Kathleen, you know what they make those out of? It's some type of synthetic,
It's a composite, yeah.
some type of plastic.
Okay.
I really don't have a good answer for you.
That's fine. Just pure curiosity.
Yeah.
Not really related.
And it's amazing the technology and how advanced they've become on these units. I feel like I installed the first RO system that came to Indianapolis back in 1979. I went to a special school. Had to go to school in Florida for 2 days to learn how to do all this stuff. But back then, the membranes were rated at 5 gallons a day, is all those membranes would do. So over the years, we've seen this technology develop to now where you have membranes that are 50, 75, 100 gallon a day systems. Aqua Systems designs and installs a lot of systems. If you get into commercial jobs where they need 1,000 gallons a day or 10,000 gallons a day, we spec and build RO systems that'd be bigger than this table here to meet certain needs. So we're there to partner with you and help you through that process. If you get into some big jobs, give us a call. We need to know how many gallons a day that company's going to use and how many hours a day they're running their shifts, and then we can help you size an appropriate RO system. Something else I wanted to cover that came up during the break, that Kelson asked this question about, again, the carbon filters and the lead filters. Let me just clarify that, again, this Pioneer system is designed to remove lead, but it also has a Centaur carbon filter built into that process that will remove chlorine and chloramines. Now, I believe that Kelson has one of these style of filters with the head on it, and he says, the question was, will that remove the lead? No, it's not going to take the lead out. It's basically going to do the chlorine and the chloramines. Since it's on Indianapolis city water, we want to make sure that we're using what we call a catalytic carbon. So there's different types of carbon out there. We've got just regular coconut shell carbon, and then we've got a catalytic carbon that we need to use when we're taking chloramines out of the water. So the question is, Kelson has, we're not sure what he's got on his filter, but if you're on Indianapolis city water, Bargersville. Well, you need to check and see what they're using as disinfectant. If they're just using regular chlorine, you're fine if it's not catalytic carbon. If they are using chloramines in their treatment, then you're going to want to change that to a catalytic carbon in order to do full removal of those chloramines. So, again, we've gone over a lot of different technologies tonight. These are point of entry systems, POE. You hear that term? This is going to go water when it comes into the house before it goes to the distribution lines. Our point of use is going to be our RO systems that go at the individual sink or the place where we want to use the water. Okay. Wrap it up. Any other questions? Listen, I want to thank you for coming tonight. I know I've thrown a lot at you. I know you've worked all day and you got to go to work tomorrow. So Jane's going to pass out some